if you look at this graph here, there's a place whereby this graph is turning. If you look at f of x, can you see f of x? F of x, there's a place whereby this graph is going to be actually to be turning. In grade 10, the y-intercept and the turning point, they are exactly identical. In grade 11, they change, they are not the same. For now, in grade 10, the y-intercept and the turning point, they are exactly what? Identical. So if they say to us, determine the coordinates of the turning point, they will tell us, determine the turning point. When you come and check, where is this graph turning? You can see, man. You know turning, yes. Yeah, but this graph, if you look at it, this graph here, it was going down, going down, going down, going down, going down. After it gets here, it turns and then it starts to go what? So there's a place whereby the graph turns. Where is that place? That place is at what? At A. At A, the graph did what? It turned. So what is going to be the turning point here? How would you get the turning point? You get it exactly the way you would get what? The y-intercept. How did you get a y-intercept? We said x is equal to what? So we're going to have y, which is going to be equal to 2, 0 all squared, minus 2. Your hand was up, Khalid. Yes, you wanted to ask me what?
Is C identical? Why turning point there is?
It's because y, the y-intercept and the turning point is exactly the same thing, only in grade 10. It's only applicable only in grade 10. Yes. So when I said they're identical, look at what is the y. I'm sure we did this question. It was number A. Number A, they said determine the coordinates of A. When you got the coordinates of A, you got them as what? You got them as 0 is to what? Is to minus 2. Look at what is the turning point now. The turning point now is still 0 is to what? Is to minus 2. So they are going to be exactly identical. But you should, what am I bringing forward to you, man? I'm bringing the word turning point, which is only associated with the what? With the parabolic function. A straight line doesn't have a turning point. A straight line doesn't turn. A hyperbolic function doesn't turn. It doesn't have a turning point. An exponential doesn't turn. It doesn't have a turning point. Now, what do they have, all of them here? This one is the only one which has a turning point. But all the functions that we're doing, they have something called a domain, and then they have something called what? A range. What is a domain? Domain are values of x, possible values of x. What is the range? Range are possible values of what? Of y. Now, how do you remember this one here? We have domain, and then you have the range. How would you remember this thing here? You're going to remember it by saying, which one comes first between D and R? Which one comes first between D and R? It's D, né? Which one comes first between X and Y? Yeah, so I'm going to say this is X is to what? Is to Y. So they can ask you either the domain or they can ask you the what? The range. Let's start with the domain. Domain are possible values of what? Of X. How do you get the possible values of X? We're going to use what we call a vertical line. Remember, we said X is equal to 0. It was a vertical line. That's what I'm going to do, man. I am going to take something called a vertical line, a line that looks like this. And then with this line here, I am going to look at, with this line here, I am going to look at f of x. I'm just going to be concentrating on f of x. Okay, look at this. If I go and then concentrate on f of x, I want to be here. Yeah, just here. Yeah, sharp. So for the domain, which is the x values, look at this. X values can change. And if I shift this thing here, if I move with this thing here, the x values can change. If I move with this thing here, the x value can change. X is minus million, x is something, minus 5, x is 7, is minus 7, x is what? Can you see that? As I move with this thing here, I am going to touch the graph. What is the first thing that I touch on this graph here? You look at that. What is the first thing that I touch on this graph? It's an arrow, né? Yes. So what does an arrow represent in math? We say which is infinity. So it means which I'm coming from negative infinity that side. Yes. And then if the graph doesn't break, you're going to check if your graph breaks. One graph which can break, which you have a piece of this graph and then you also have a piece of another graph. With this one, you can say the graph is solid. There's no way it's breaking. So the first thing that I touched was infinity. So I'm going to tell them this way. I'm going to write it this way. I'm going to say which X is an element, and then I'm going to use a curve bracket from negative infinity. Ne? And then I'm continuing with this thing here. If I continue with this, I am going to have, it's a solid line, it's a solid line, it's a solid line, up until I get to the other side. What is the last thing that I touch? It's an error again. Yeah, the error of the positive side, we call it what? Positive infinity. We are going to do activity number 5. No? Yes.